Okay. Good morning. Hello, everybody. Thank you for being here. Thank you for Daniel Katz for being here, accepting our invitation. This is the second, the international keynote for our event. And it's a pleasure, really a pleasure to have you here. And now we are going, we'll have his presentation towards sustainable research software. So Daniel Katz, right now he's the chief scientist at the National Center of Supercomputing Applications, and also a professor, a research associate professor in computer science, in computing engineering, electrical engineering, and also with links with information science school. And the University of Illinois, Urbana-Champaign. So his talk is about a very interesting theme. At least I think it's very important for all researchers besides computing science. And this, we have open science and open data that is very well known, and some researchers here interested, but now also we recognize the importance of, we try to recognize the importance of academic software in this ecosystem, research ecosystem. And I think we must start the talk. So thank you, Daniel, and please you may start your talk. Thank you.
Okay, thank you. All right, so hopefully this is working and everybody can see and hear. I'm sure somebody will tell me if they can't. I'm going to talk about sustainable research software, but before I do that, I just want to thank the organizers for giving me the opportunity to speak here. I think it's been interesting to me to see the uptake of some of these ideas around the world, and it seems like there are now a community of people in Brazil who are very interested, which is good. So I hope we can expand that community and make further progress globally. I can see chat messages, but I'm not going to actually look at them while I'm talking. So if there's something important in the chat, somebody I hope can please speak up and just interrupt me. Okay. All right. So to start off, I think in general, as scientists, as researchers, we want to collaborate. And to me, this is what really is the purpose of open science and the goal of open science. It's the free sharing of scientific ideas, methods, and results. But it's not just science. So this is a language issue a little bit. In English, the word science is somewhat limited. In German, the word Wissenschaft is much more broad, meaning knowledge or scholarship. In Spanish, ciencia, and I'm sorry, I'm not sure in Portuguese, but and so I don't actually know kind of where the Spanish and Portuguese word falls, but I just want to say that when we say open science, we don't really mean to limit it to science. We really mean to work in scholarship in general. So this collaboration was originally done via handwritten letters and books, mostly for other scientists. And then it moved from these handwritten letters to kind of letter clubs, where people would send letters to multiple people, letter rings in some sense. And then when printing started, this moved into the idea of putting these letters into printed volumes, into journals, and expanding the audience, not just to the people that you wanted to send your results to, but other people who may also be interested in your results. Because we've moved into a more digital age now, this has expanded the opportunities for sharing as well as what could be shared. right? We don't just now share text, we can also share software, we can share data, we can share interactive activities as well. And the democratization of research in general, and primarily due to public funding that's really been since World War II, and information sharing systems, initially bulletin boards and then the web, has expanded the community that can read things, that can actually be involved in the sharing. So this leads us into this idea that knowledge is a common or a societal good. And the open science term, as far as I can tell, was documented first in the journal Science in 1882. But there it had the sense of using the scientific method, which is certainly good, but didn't really have the open sense as much as we would use it today. I think that the open science, the sense of open science and openness, really came about, it appears to me, in the mid-1980s, when there was a American Academy for the Advancement of Science project on secrecy and openness in science and technology. And it seems like this led to the open science movement, or at least the name open science associated with that movement, as far as I've been able to tell. Okay, so even though we want to share things, we also compete with each other. And we do this because economics really is a driver for a lot of things. We live in a capitalistic society, and economics drives where we work in terms of hiring. When we compete with other people, it drives how we support ourselves in terms of competing for promotion opportunities. It drives how we get funding to do science, which in turn is based on support and recognition. It drives what science we do, right? We tend to work in areas that we think will lead to a reward. And it also, in some sense, drives which students we train. Economics overall is defined often as the science of allocating scarce resources to maximize the achievement of competing ends. And this isn't always a true argument, because some resources can be increased without cost, and thus they're not really scarce resources. And so science, in some sense, the results of science you can think of as not being scarce. But the scientists maybe are scarce, and so we're kind of in a strange state where we're again working in both a wanting to share methodology, and where sharing is free, along with a competitive economy where there's a cost to competing. So people are complicated, and as I said, we do both of these things. In general, if we're interested in working together, we're interested in engagement. We want meaningful and valuable actions that produce a measurable result. We want to engage people in our projects and reading our material and helping us develop our software, etc. This engagement effectively is also choosing when and where to come together to do something, right? Why people make these choices and how they actually make them. And you can define engagement as motivation plus support minus friction. And motivation has two different parts. One is intrinsic, the things that are internal to you, the reasons you act. And the other is extrinsic, the things that are external to you, but again, the reasons that you act. The support part of this is making it easy for you to do any of these things, to become engaged, to work together in a community. And friction are the things that actually then prevent you from doing this. So we, to some extent, at least at a high level, understand why people might choose to come together and we also have this competition piece that may keep them from doing so. There's a set of reasons why people don't collaborate if you ask them, why people don't open science. And I just want to go through some of these briefly. So one of them is that sharing takes effort, and the immediate benefit of the sharing go to other people. Right? There's a long-term benefit of sharing where you get new collaborators and your work is improved, but it's not immediate for you. There's often embarrassment about details. Right? People say, I don't want to share my code because people will see what a sloppy job I did, or how I don't know best practices, or something like that. There's the fact that the people that share, let's say, data, don't want to support others. Right? Maybe I'm happy to give away my data, but I don't really want to spend lots of time answering questions about it. The mechanisms of sharing are new, and they're not the way we work traditionally. This isn't necessarily the case for students that are starting, but this kind of gets re-emphasized and reinforced for people that have been involved in science and scholarship for a long time. The metrics for evaluating products that can be shared are underdeveloped, right? So we don't have good ways of saying, I created the software, who's actually using it, what are they doing with it? There's also intellectual property laws that may, in some countries, hurt efforts toward sharing. There's commercial entities who can profit from restricting access. So, for example, papers, digital papers could be completely free. But if there's a company that can make money from selling access to those, then they want to limit access just to the people that are paying that money. So that's another issue. And then finally, even when we think about nonprofit societies, they're often dependent on journal subscription fees or perhaps open access fees, not just to support the journals and the papers, but also to support themselves as a community. So a particular society may make, I don't know, let's say half of its income from journals, and it uses that to support conferences, it uses that to support local groups, talks, other things. So in some cases, maybe this is reasonable to do, but we have to really think about it more openly, I think. Okay, so having talked about science in general, let me focus on research software a little bit. Let me ask why we care about research software. Really, what I'm going to do is kind of answer a question of why do we care about research software? I think there's three different ways we can look at this. One is we can look at funding. And if I look at three different US funding agencies, the National Science Foundation, Department of Energy, and National Institutes of Health, the data for these is very hard to find, but I can find something like close to $15 billion of funding that's gone into projects that are developing software or maintaining software or doing things like that across these agencies. And I think this is a dramatic undercount. This is just an area where we don't really have the right data to give the answers we'd like. We can look at publications, where we can see that software-intensive projects are a majority of current publications. And the most cited papers are papers that are either about methods or about software. And you can often think of software as an implementation of a method. And we can also ask researchers. And when we've done this for US and UK researchers, we've found that greater than 90% use research software. About 2/3 would not be able to do their research without research software. And about 50% develop software as part of their research. And again, I want to point out that this is across all fields. This is not just computational fields or data fields. This is including, I don't know, humanities, for example, where you may not be thinking about research software as one of the important factors. Okay, so having said that, then let me give a brief vision of where research and research software might fit. And so I would like to imagine a world where all research software that can be is open, where all research software is high quality and robust, where all research software is findable, accessible, and usable, and also is actually used by others for their own research, and that it's cited when it's used. That all contributors to research software are recognized for their work and that they have good careers. That all research software is sustained and continues to work as long as it's useful, and that all research is reproducible. And so all of these things, if we want to imagine how these could happen, have overlaps in terms of incentives and policies. And they all start with the recognition of the importance of research software, which I was just trying to speak about on the previous slide. The reason that some of this becomes important is because of something called software collapse, the fact that software does collapse. Software stops working eventually if it's not actively maintained. We have computational science software stacks that you can think of as having some structure, where down at the bottom is a non-scientific infrastructure, things like operating systems and compilers and support code. And then on top of that is a scientific infrastructure. These are libraries and utilities that cross multiple disciplines. On top of that then is discipline-specific software, tools and libraries that implement disciplinary methods and models. And then on top of that is the project-specific software used to answer a specific research question, using building blocks from the lower levels and combining them in some way, let's say scripts or workflows or notebooks or special purpose libraries. And of course, below level 4 is the hardware itself, the systems. And so we have the fact that the software that's up at the top that you're using to try to answer one research question builds and depends on the software and all the layers below it. And any change below may cause your software to collapse, right? If the operating system changes, if the compiler changes, if the library API changes, if the application that you're using in a parameter sweep changes, all of those things can cause the software that you're running to collapse. So this leads to a set then of challenges. We have the fact that research software is the software that's developed and used for the purpose of research to generate, process, analyze results within the scholarly process. It's increasingly essential within the overall research process. But these challenges include the fact that software will collapse if it's not actively maintained. Software bugs are found in almost all software, and new features are needed in the software, and new platforms arise, and all of these then require maintenance in order to keep the software working. This software development and maintenance is human intensive. We don't know how to automate it in general. And then there are also human challenges that go along with this. Right? The software is generally developed specifically for research by researchers. These researchers know their disciplines, but they often don't know software best practices. The researchers are not rewarded for software development and maintenance, at least not in academia. They may be in industry. And then finally, we have the issue that developers don't match the diversity of the overall society or even of the user communities. So if we think about work in a particular area, we have lots of people that want to use that work, but we only have a limited subset of them that actually are allowed to contribute. And if we could open the contributions up to include really the full society, the full user community, we would have more people that could work. We would end up with better, more sustainable, more maintainable software. So I'm defining then software sustainability as the fact that the software endures. And so questions then include if the software is going to continue to be available in the future, if it'll be available on new platforms, if it will be available to meet new needs. And you can only measure this looking backward. If you want to try to look forward and say, is the software sustainable? You really can't. It's a prediction. You can say, we think it will be sustained, but you can't really be sure. As I said, software development and maintenance requires active human effort. Human effort is kind of equivalent to money, but not exactly. We can have projects that are entirely based on human effort, community open source projects, and we know that those can be successful. We can have projects that are entirely based on money, on salary. And this we know works. This is how commercial software works. This is how grant-funded projects work. It's very hard, though, to combine these two things because effort is not exactly the same as money, and people are not purely rational. So if you try to have an open source project where some people are being funded by a grant from a funding agency, and then you ask other people to volunteer their time, that can be a little bit tricky sometimes. So to define research software sustainability then in words, it's the process of developing and maintaining software that continues to meet its purpose over time, which includes that the software has new capabilities as needed by its users, that it responds to bugs and other problems that are discovered, and that it's ported to work with new versions of the underlying layers, including both software as well as new hardware. So we have some potential solutions to this. In fact, really 3 of them. We can do things that reduce the amount of work that's needed to sustain the software. We can do things that increase the amount of available resources that go to sustaining the software, or we could do both. We could try to reduce the amount of work needed and increase the available resources. And all of these can be done. If we want to reduce the amount of work that's needed, one thing we can do is to train developers better. Which means that we need to find or develop better training material. The carpentries is a good way of doing this. There also is some discipline-specific material coming, some language-specific material. Researchers often don't know about these things, though, and may need to be pointed to them. We can also use best practices, which involves finding or developing those best practices. And I think this is an area where the software engineering community really can help. particularly in thinking about best practices for research software engineering, not just for software engineering in general. Again, software carpentry works in this space, and then there are also incubators working in this space where particular projects can go to learn about best practices and to work with experts. If we want to increase the available resources, we can create incentives so that people want to work on the software. We can think about citations as one of these things that help in existing career paths. And I'm going to talk about this then in one of 3 sections coming up. We can think about adjusting existing career paths to better reward software work. And we can think about new career paths. And I'm going to talk about that in the second of the 3 areas coming up. We can also think about increasing the available funding by making the role of software and research clear to research funders, like funding agencies, and then clearly making the case for them to increase funding for new software and to provide funding for software maintenance. One of the issues now is that software funders, research funders, funding agencies often are interested in funding new things. Sometimes they think of them as shiny new things, but they don't necessarily want to support them after they've been created. And this is not just a question about the funding agencies, this is also a question for the review panels, right? Because the funding agencies aren't making decisions on their own. If reviewers think that it's worth doing something new, but they don't understand the reason for maintaining something that exists, that's also a problem. We can also think about seeking institutional resources. So in my case at the University of Illinois, at the National Center for Supercomputing Applications, we have some software that we really think of as important to us. It's important to us both in terms of supporting ongoing projects as well as our reputation. And so we support that software to some extent, maybe not to the extent that I would like, but to the extent that we can. And then finally, the third option of reducing work and bringing in new resources. The one great way to do this is to encourage collaboration. And so if you can use the work of others rather than re-implementing a function or package yourself, this reduces the things that you have to do, right? You can use this work and you can focus on the things where there isn't existing software rather than re-implementing the existing software as well. You also may, by doing this, get other people to contribute to your software. Which also could happen. If others are using your software and contributing to maintaining it, then this means that you have less that you have to do on that software again, and you can focus on other things. In order to make this work, though, software has to be designed from the start to be modular and reusable. And it also has to be clearly documented and explained to potential users, even those in other fields than the developers. And the team has to put effort into engaging and working with the potential user and contributor community. So you don't get this for free, but hopefully you put less effort into this than you would of entirely building and maintaining the software yourself. So one way of thinking about this then is if you can make your software and others make their software as well, findable, accessible, interoperable, and reusable, then others will work on it, can at least use it. And vice versa. And so that's then going to be the third of the 3 different topics I'm going to talk about, fair for research software. Okay, so let me jump into the first then of these 3 topics, software citation, and I also want to talk here about the Journal of Open Source Software, which is a little bit different, but is connected to it. In 2015, Force 11, which stands for the Future of Research Communication and eScholarship, was interested in having some work looking at software citation. And Arfin Smith and I started this group, and we were later joined by Kyle Niemeyer. We did a bunch of different activities. We documented a bunch of differences between software and data, and we defined software citation challenges. And we published 2 papers about this. And then working with a community over this 2-year period, really about 18 months, we created a set of software citation principles, starting with the data citation principles that had been developed earlier in this period, and then trying to adapt them based on the differences between software and data. Let me just kind of show you what this looks like then. So we have 6 principles for software citation. This compares to 7 for data citation. One of them is importance, which is saying that software should be considered in a legitimate and citable product of research, and software citations should be as important as any other kind of citations. Credit and attribution says the purpose of software citation should be to give scholarly credit and attribution to all contributors to the software. Unique identification says that the software citation should include a method that's machine actionable, globally unique, and recognized by experts and by the public. Persistence says that the unique identifiers and the metadata about the software should persist even if the software itself is no longer available. Accessibility says that the software citation should facilitate access to the software itself and to its metadata. And specificity says that software citation should facilitate identification of and access to the specific version of the software that is being discussed. So we had these 6 software citation principles. We published them, people got interested in them, and we started a implementation working group to actually move forward with them. And in this group, I was working with Neil Chu Hong and Martin Fenner. I guess I should say I am working with, because this group is still going. Our initial goals, we thought, were to write out what we believed would be a small amount of detail that would be needed to implement the principles. And then we saw different groups working on these, and we wanted to coordinate these groups, and then to work with communities to make sure the principles were actually implemented. We fairly quickly realized that the small amount of detail wasn't really small, and that the scattered progress that was going to happen wasn't sufficient, and that the underlying challenges actually weren't being addressed. And so we wrote a paper on what these challenges were. And the technical challenges include the fact that software is very complex in terms of its types and identifiers and where metadata actually is stored. And the social challenges include the fact that we need different groups working in different contexts in terms of disciplines, in terms of publishers, in terms of repositories and registries, et cetera. We need those groups to come together and run pilots within their own context to establish norms, and then to talk with each other to make sure that what we're doing makes sense across the entire software ecosystem. So in response to those challenges, we've done a bunch of different things. We created a guidance task force that has published guidance for softwares who want to cite, for paper authors who want to cite software, and for software developers who want to make their software citable. And both of these guidance documents are in the form of checklists. We've had a task force on metadata, and particularly using the Code Meta project, which was looking at how to understand metadata for software, not just in citation, but more broadly. Code Meta built a crosswalk of existing metadata standards for software, and then it developed its own standard to describe software that was based on all of these different existing standards. And what we've done in the task force has been to update the Code Meta standard to describe everything in Code Meta using schema.org properties, and to turn Code Meta into a community group where we govern this part of schema.org, but we don't actually maintain our own standard any longer. We also have a task force looking at registries, software registries that want to hold software. And we looked at what those registries need to do in order to best hold research software. We created this document about 9 best practices for research software registries and repositories. And this community then has come together where these different registries and repositories can continue meeting and continue working on best practices. And it's called SciCodes, and it's open for anybody to join. I guess I should point out at this point, there's a DOI that's on the bottom of all these slides, and that is the DOI to these slides. And if somebody wants to put that into the chat for other people to click on, or into the YouTube link, that would be great, and I would appreciate it. But that's a way of clicking on any of these links or citations that I'm providing in the slides. We also created a journals task force, and the journals task force has been working with publishers to provide provide to them a set of generic guidelines for journals and conferences to then provide to their own authors. The idea is that the journals and conferences would take the guidelines that are using one particular citation style, and they would use their own citation style, and they would use examples that fit their discipline. And we've done that as a paper And one of the interesting things about this paper is that it has, I think, about 19 different publishers as co-authors, indicating their commitment to doing this. And then we've also built within an industry group a software citation policy index where different publishers can look and see where other publishers are, as well as the fact that authors can look and try to understand what publishers are asking for in terms of software citation. You can also look at publication processing. This turns out to be kind of a tricky area. As you know, when you submit a paper to a journal, you often provide some text that's something about the citation. The journal then has a bunch of internal processing steps that eventually lead that citation to being registered with Crossref. And Crossref then is the thing that in some sense enables the indexing that Google Scholar or others do, that leads you to be able to see who cited your paper or your software or something else. And it turns out that this works reasonably well for papers, but it doesn't necessarily work so well for data or software. Parts of the citation can get lost along the way during this internal processing. And if you have a software citation, you may not be able to see all the people that have actually cited your work. And so we have a paper that I think has just been submitted to publication, or well, at least to review, for this to help journals understand good practices to prevent some of these problems that happen with data and software. We also thought about an institutions task force, thinking about institutions as the place where people work, like universities or laboratories or industry. And our goal was to think about policies and practices that happen within these institutions, how the institutions encourage software citation, how they use software citation information in hiring and promotion. And what we wanted to do was to collect and share examples and to help form communities. But it turned out we didn't have enough interest from our working group members, and so this is on hold currently. And then finally, we've been thinking about, since this group has been going for about 5 years, where are we now? What else should we do, and who can do it? And a couple of months ago, we had a software citation workshop that was intended to assess where we are and to plan next steps. And a report for that is being drafted and should be public in the next couple of months. Okay, so that's software citation, citing software directly. In addition to citing software directly, people write papers about software and then they cite those papers. And the Journal of Open Source Software is intended to be a means to do this. It's a developer-friendly journal for research software packages. We believe, and at least we say, that if you've already licensed your code and have good documentation, it should take less than an hour to prepare and submit a paper about your software. Everything about JOS is open. The submitted and published papers are open. The code itself, the software that's being reviewed, is open. The reviews and the process are completely open. And I do want to kind of highlight this because this is an interesting thing. We do our reviews as GitHub issues. And so anybody can see who the reviewers are and the process of the review and where things are. We adapted this from our OpenSci. And we have then an expedited process for software that's already been reviewed by our OpenSci or PyOpenSci. Right? If the software has been reviewed by a community that we trust, we don't need to re-review it. We can just work on some of the other issues about the paper itself potentially. The code for JOS is also open. And so it has been reused for the Journal of Open Source Education, JOSE, as well as the proceedings of the JuliaCon conferences. And if you're interested in starting your own open journal, you can use our code and you can do that as well. JOS papers are archived and they have DOIs and they are increasingly indexed, although indexing has been a challenge that has been very slow to work with different groups, such as, for example, publishers that own Web of Science or things like that. Where we might be competing with their journals. It's been interesting to try to get them to list our papers as well. The first JOS paper was submitted in May of 2016. About a year later, we had 111 accepted papers and 56 that were under review and pre-review. As of earlier this week, we had 1,700 accepted papers and about 220 that were under review and pre-review. We're currently at about a paper a day, and we seem to have reached kind of a level point, but I'm curious if we end up kind of going back to a growth model, which I kind of expect we will when we do a few things in the near future. We started with 1 editor-in-chief and 11 editors. I was a co-founder and I was one of those 11 editors. And today we have 1 editor-in-chief, 5 associate editors-in-chiefs, including me, 62 topic editors, and 32 emeritus editors. We ask editors to serve for a year or 2, and then they can renew or they can choose to step down depending on what their interests are and how tired they might be. And we'll also be moving to a track-based model very soon, where we'll have topical tracks rather than just looking across all papers, which I think is one of the things that may increase our rate as we go forward. JOS is a journal, but it's also a community. And it's worth thinking about the fact that culture changes based on rules and incentives. And we think that JOS practices have influenced reviewers and developers in terms of what's good and what's minimally acceptable. And again, this is an area where I think software engineering comes in to some of the aspects of this talk. I think what we've done has been similar to our open science influence in the R community, but a little bit more broad. And we've had a set of minimum criteria for successful review. And those criteria have changed over time as community best practices have developed. So we really have, I'd say we've changed our criteria for packaging, for what's required of software in order to be acceptable, for testing and continuous integration, and for documentation, just as examples of things that change. And again, as community practices change, I think our criteria will change to match. We try to use our criteria to say, here's the minimum that's acceptable. Here's something that would be even better that we would love to see. And when people do those things, it changes the best practices, and gradually those become the minimum, and we can think of new best practices. We, as I mentioned, are applying open source software practices to reviews. Right, so open source software is open from the beginning and welcomes contributors. We do the same thing. We make our reviews open, and we do them in a spirit of collaboration where reviewers are not trying to judge something that's been submitted, but they're trying to help improve it to the point where it can be published. We provide rules, and at a high level, we try to nudge incentives. We're trying to effectively make accepted software equivalent to an accepted paper. And one of the reasons we're doing this is that software citation is really a new idea, and it takes time to make this something that happens. And in the meantime, we'd like to think about just having a paper as in place of software, something that's easier to fit into the existing scholarly system. If we do get to this point where software is cited directly, and that's common, then we won't have a need for JOS papers any longer. But the JOS review process and the JOS community will still have great value. And so we're really thinking about how could we move to this future point? How do we turn JOS into a open, collaborative, contributive review community that thinks about best practices and also helps individual projects? Okay, so moving on to item 2, research software engineers. Research software, as I said before, really comes from research primarily. This has been the case from the beginning of computing. It seems that software appeared around 1948, as best I can tell. Research software really started in the early 1950s, very soon after software. While software engineering really started in the late 1960s, it seems like it was mostly initially applied to operational software, like operating systems, sharing systems, NASA flights. When software engineering started being applied to research software is kind of an interesting question, and even whether it is an interesting question as well. Again, as I said, we have the fact that researchers, particularly faculty members, graduate students, generally don't know good software practices. Software engineers generally don't understand the research context. And again, this is one of the issues with software engineering, is that software engineering often does not understand the general disciplinary research and has difficulty applying software engineering practices to research. And this is part of what we're trying to work on, really bringing these communities together. Students and postdocs generally don't know good software practices when they start, although they may learn them from their peers over time, but then they graduate. And some postdocs do stay, and sometimes they will join the staff of a university or of a research group. Sometimes this is unofficial. You might not call them a staff member, you might call them a postdoc, and they might be a postdoc for a really long time without any permanent career. But over time, we do get some staff that have really an understanding of research as well as software engineering skills. And so we can think of this in the context of two different archetypes, in some sense, the craftsman and the scholar. The scholar is the researcher who's driven to understand things to their fullest capacity. They want to find intellectually demanding problems. These are curiosity driven. They want to work on a topic until they understand it, and they pass that understanding on through teaching and maybe through publication as well. They want to write something proving that they've understood something and maybe helping other people understand it as well. The craftsperson, on the other hand, wants to create artifacts. They want to create an artifact that shows that they really understand something and they can build a tool that's useful to others. They feel pain when the things that they make are fragile or ugly. They prefer to make things that explain themselves. And this kind of work requires patience and pride in doing a job well. Scientific software then needs people that can combine the best of both of these roles. And I want to point out the URL that's down at the bottom was written in 2012. And this is when kind of this thinking about research software engineers really started. And specifically, again, I'm kind of hinting about research software engineers, but without defining it. So let me define it slightly. That we can think of a space where we have software engineering expertise on one area, one axis, and research expertise on the other area, the other axis. And on one side, we have software engineers, and on the other side, we have researchers. And then in the middle, we have researcher developers. And these are typically the people that are building software to do their own research and to do research in a community. And they really, again, have very strong research understanding, but they may have less software engineering understanding. And so research software engineers really are intended to kind of be in this middle. And it's not exactly a point in the middle, it's really kind of a fuzzy space in the middle. So again, this is research software engineers as we're talking about them, people that understand software engineering, understand research, and can apply the two together. In 2012 in the UK, there was a workshop called the Collaborations Workshop. And a working group in that workshop realized that there were a lot of people that were doing work like this already. They found that there was no common title for these people at this point. There were 194 different job titles that they found for people that were doing this kind of work. And so they came together and they decided that they would use the term research software engineer, which is not necessarily the ideal that any one person would have chosen, but it was the best that they could come up with. And it's what the community has coalesced around. They really realized that there was no community around this as well. And so they created an initial association, which has grown into other associations and a society, which I'll talk about. And they realized that this wasn't a profession. And so they started doing work to build career paths and to build structure around this so that this could become a profession. So this work's been going on for 10 years. As I said, this movement and the term were born in the UK. In late 2013, the UK RSE Association formed and had about 50 members, and that now has turned into a professional society with about 600 members who are paying dues and about 4,000 members overall. There also are associations in Belgium and Germany and the Netherlands and the Nordic countries and in Australia and New Zealand. And there's an association also in the US where we now are up to about 1,300 members. There are also new associations forming in Africa and Asia. Work on local issues, they can do this collectively, and they can coordinate both in terms of coordinating across their own country and region, but also in terms of coordinating with other associations. And so this is where we are now. The dark red areas are places that we have RSE associations. The lighter red kind of dotted areas are places where there is work going on. And then the gray areas are places where we don't know of work that's gotten to the same point yet of turning into a formal organization. And I'll just mention that one of the things that I would love to see coming out of this, and that there's been some interest in Twitter from the talk Alfredo mentioned that I gave last week, but also before then, would be either a Brazilian RSE association or potentially a Latin American RSE association. And so if anybody is interested in either of those, let me know and we can try to build some community. Somebody just wrote to me yesterday on Slack in the US RSE Association asking about this. And so I know there's some interest, but some people locally will have to want to do this enough to put energy into doing it. I think it then could be successful and could be a movement to lead to better software and better research. So the reason that RSEs I think are good is that they can lead to better software and more mature project management aspects and structures. Excuse me. This can help better organize teams, can help better organize work, can help better organize software, and can bring in better coding practices, then leading to better, more sustainable software and more efficient group coordination if you're thinking about faculty-led groups in particular. They also provide institutional memory. As research software becomes more important and more complex and more costly, the expertise in it is valuable. RSEs can have longevity beyond individual projects and students, and they can be mobile across domains. So they can preserve this knowledge and this memory from one project to another, from one domain to another, from one group of students to another. And they also then build community expertise. And because RSEs typically work on grant-funded projects, less than one person per project often, these projects have a shorter duration than the staff member's career. And so these RSE groups tend to work towards a form of matrix management where they have a principal investigator, the person that's actually leading the work that they're working on, that changes over time, and it's funded by the individual projects that are available. And then they also have a group organization where there's typically a group manager, and this is the group that forms the peer of other RSEs where the manager is the person that's concerned about their career and their training and how they move forward over time. These RSEs then overall become a pool of experts and expertise, and they can help others with shared interests. So people at a university who aren't RSEs but want to learn maybe how to do something can learn from the RSEs who have been doing it for a long time and have worked across multiple disciplines. Okay, and then the third of the things I'm going to talk about is FAIR for research software. So we have the FAIR principles. Again, FAIR is findable, accessible, interoperable, and reusable. These principles were written in 2016 and published in the paper at the top right. And they're a set of principles that are intended to ensure that data are shared in a way that enables and enhances reuse by humans and machines. And so I'm not going to go into this in detail, but I'll just say that there are, the principles look at findability of both metadata and data, that they have identifiers, for example, metadata describing the data, accessibility, the metadata and the data are retrievable from their identifier, interoperability, that the metadata and the data use a formal, accessible, shared, and broadly applicable language for representation, and reusability, that the metadata and the data have accurate and relevant attributes to enable the data and the metadata to be reused. So this has really been the case for data, but if we think about other objects, we have the fact that the FAIR principles at a high level in that paper I mentioned in the previous slide were intended to apply to all research objects, both those that are used in research and those that are research outputs. As you saw, the text and the principles often included this phrase meta in parentheses data, and this is shorthand for metadata and data. And it was a way of saying metadata should do this and the data should also do this. The principles are applied via dataset creators by people that make the datasets, as well as via repositories. And collectively, these two different sets of organizations are responsible for creating the datasets, which needs to happen first, and then for annotating and indexing and preserving and sharing the data sets and their metadata, which happens second and is generally done by the repositories mostly. As I've just said, this implies, it assumes that there are separate and sequential creator and publisher roles. If we think about non-data objects like software, for example, can be stored as data, but they're not just data. The ideas of making other things findable, accessible, interoperable, and reusable are typically very similar, but the details of how that's actually done depends on how these objects are created and used, like how software is created and used, for example, how and where objects like software are stored and shared, and how and where metadata, again, for example, about software is stored and indexed. So there's work that's needed then to define and implement and adopt FAIR principles for these other kinds of objects like software. As I said before, the FAIR principles were intended to apply to all objects, If we look at recommendations, we can find that the European Open Science Cloud, EASC, had as one of its recommendations to recognize that FAIR guidelines require translation for other digital objects and to support these kinds of efforts. The French National Committee on Open Science had a project group on free software and open source open source, and they recommended that the specific nature of software be recognized and that not be considered just data, particularly in the context of discussion about FAIR. So there's some activity that I'm going to talk about that focused on how to adapt the FAIR principles to research software and then how that gets adopted after it has been created. Again, software versus data. Software is data, but it's not just data. Some reasons for this is software is executable while data is not. In general, data provides evidence while software provides a tool. Software is a creative work, again, in general, where scientific data is facts or observations. They have different licensing and different copyright practices. They're treated differently legally. Software suffers from collapse, while data just suffers from bit rot. Software, of course, does suffer from bit rot as well, but it's not really a big issue compared with software collapse, which I mentioned earlier. The lifetime of software is generally not as long as that of data, although again, this is a generalization. And finally, and maybe kind of more interestingly, if we're thinking about open source, there's no kind of natural sequential creator and publisher process, and no natural publisher. There's no reason necessarily that open source should be put into a archival repository, like a data repository, for example. And open source can be used by people from the time that it is created, even before it's finished. There's no point at which it gets finished and gets published, although there can be releases, which I'll talk about briefly. So again, there is a group of us that has been doing some work to try to define a consensus set of FAIR principles for research software. There are 9 of us that are the co-leads of this activity. And we did this with working with 3 different standards organizations, or 3 different community organizations. Force 11, which I mentioned previously in the context of the software citation work. The Research Data Alliance, which is the area in which the FAIR principles were originally created for data. And RISA, the Research Software Alliance, which seems important in the context of research software. We wanted to work with these 3 different groups in order to get as much as possible consensus and community buy-in, both to what we were doing as well as the results of what we did. We define research software as source code files, algorithms, scripts, workflows, executables that are created during the research process or for research purpose. And we recognize that there are additional software components like operating systems, libraries, other things that are used for research, but were not created during or with a research intent, that we would call software in research and not research software. And this differentiation varies between disciplines. So for example, if you're a computational chemist, the operating system and the compiler that you're using to do your work is software in research, but it's not research software. But if you're a computer scientist who's working on operating systems, then operating systems are research software for you. So as I said before, we developed a set of FAIR principles for research software. We did this earlier this year. I think in May or June, we published this. And I'll talk about these briefly, but one thing I want to mention as I do this is that the things that are in italics are the things that are different from the data principles. So in general, there's a lot of overlap with the FAIR data principles, but not completely. And in particular, in terms of findability, the things that are different are that we have software that has different components, different levels of granularity, projects, files, lines of code, for example. And we have different versions, right? Patches, releases, things like that. And both of these lead to differences in identifiers than data. In terms of accessibility, there really are not any differences, but this is a good point where I can point out that we cannot, for software, we can't use this term metadata. With meta in parentheses, we have to be explicit about software and its metadata, because the software and the metadata have different properties where the data and the metadata maybe were more similar. Interoperability, we really had to define completely differently than was defined for data, and we defined it as the way that software interoperates with other software through exchanging data or metadata or through APIs, and that these all should be done through standards. And reusability also is a bit different because for software, we have to kind of define what does usable mean and what does reusable mean. And so the things that are interesting about usability and reusability is that the software you can think of can be used by reading it, by understanding it. It can be reused by modifying it. It can be reused by building upon it. It can be reused by using it in other software. And typically, in order for it to be used in a general sense, it has to be able to be built and executed as well. And so that leads to some differences, mostly in terms of the relation of software to other software. So now that we have these principles and we've published them again a few months ago, we have things to worry about still. One of them is governance, to interpret the principles and to think about if future revisions are needed. And so we've set up we haven't set up, we've turned over that work to a group that exists, the RDA Software Source Code Interest Group, to be responsible for those two different activities. We have written and published a set of adoption guidelines, basically how the principles are being adopted. And then we've also looked at adopting organizations, what different funders, universities, for example, are doing with the software and how they're doing it and why they're doing it. As I've mentioned before, there are challenges that remain, like there were with software citation. And some of these challenges actually are the same, and they're particularly related to metadata and archiving and versioning. And so one of them is, as I mentioned earlier, again, that the creator and publisher sequence doesn't typically apply, at least to open source. If we're thinking about where metadata is stored, there's a lot of different choices. It could be stored in the software repository for open source software. For closed source software, it's not clear. Maybe it should be stored in a registry. We could also think of archival repositories that are used for data, potentially as being used for software and for metadata. Where code is actually archived is a challenge. We have GitHub and GitLab that use the term repository, but they are not archival repositories. They're using the same term in a different way. And so there's no guarantee that any software that's on GitHub or GitLab will be around at any point in the future, because the creators can remove it whenever they choose to. We have registries that are not archival. We do have archival repositories, things like Zenodo, for example. And we also have software heritage, which is somewhat like the Internet Archive, but is looking at open source software and trying to create an archive of open source software that can always be looked back at. We also have the fact that different use cases need specific versions of the software, a specific version. Sometimes you're interested in the latest version, and sometimes you're interested in all the versions. You're interested in the project itself, not a particular version. And so you need metadata and a way of describing each of these. There's also a lot of work that's needed beyond FAIR. So if software is findable, accessible, interoperable, and reusable, it can be bad quality. Right? FAIR doesn't say anything about quality. It doesn't have to be correct. It can have bugs in it, and probably does. And FAIR doesn't talk about that. FAIR also doesn't talk about reproducibility, and it doesn't talk about openness. So there are, again, a lot of different things to continue working on. FAIR is a particular step addressing a set of challenges, but not all the challenges. Okay, so again, having talked about these three different things, this context, let me conclude by saying that research software, I believe, is increasingly important to research. I hope I've convinced you of that. Citation is the accepted mechanism for credit in academia, and software citation is starting to be accepted with some uptake from researchers, publishers, librarians, and others. Software papers are a placeholder for software citation until software citation is fully accepted, but they also have an important community function. Research software engineers is newly recognized as a role, but really has a long history. And we're now building community and making a case for formal career paths for RSEs. The FAIR data principles set out a good goal to share data to enable and enhance reuse. And we need work in order to apply this to research software, both open source and not, to fulfill the open science concepts. And we've created a set of principles with about 500 people that have provided input and over about 60 events. And we published this again earlier this year. We're now working to create guidance and to adopt the principles and to define governance. And some future steps will be to create metrics to measure how fair software can be and to widen adoption. So having said that, then, I want to leave you with some things that you can do if you're interested in this, if you find this appealing and you want to work on this. So one thing is that you can promote software sharing and credit. And if you're an author, you can cite the software that you use. When you develop new software, you can make it easy to cite and tell people how to cite it. When you review papers, you should demand that software be cited. And if you're reviewing a paper and it doesn't cite the software it's using, say that it needs to be before you're going to say it's acceptable. And you can also work to make your own software fair. You can follow the principles to make your software findable, accessible, interoperable, and reusable. You can support research software engineers, these software developers and maintainers. You can think about how your organization, your university, your lab, your company does this. And think about if you can change it in some way within your own institution, or if you're an RSE yourself and not called that, maybe you can start talking to other RSEs and start talking to your management and say, right, this is what we do. We realize that we're not being recognized in the right way. You can look at the Society of RSE, which is focused in the UK. You can look at US RSE as another example. And we can think, is it time to start an RSE organization in Latin America or in Brazil in a single country? You can work to make sure that software work is included in hiring and promotion. So if you're on a hiring committee and you see that somebody has done great work in software, make sure that that's highlighted and that other people on the committee see that and recognize it and try to use it as an argument to hire or promote that person. You can also think about the fact that all these different communities I've talked about really are open communities, and they have some overlap as well. And so you can join one, right? You can get involved in open software and the FAIR work and citation work and RSE work, RSE organizations. For this community in particular, I think it's important to understand that research software is not business software. It has different goals, it has different incentives, it has different methods, it has different practices, it has different workforce, and it has different education and training needed. We need work on research software communities as well. We don't really understand at this point what governance models work under what conditions. We don't understand how to effectively run projects that include both paid staff as well as volunteers. And we don't understand how to increase diversity and inclusion within these communities. So these are, I would say, three big areas where there's a huge amount of research that's needed. We also need research on how to avoid software collapse with less human effort. We need better automated testing and continuous integration, particularly for research environments like high performance computing, where every system is different and CI has a lot of interesting challenges. We need software that adapts to changes in the APIs of its dependent software rather than just failing and saying that a person needs to figure out how to fix this. And we need more portable software, particularly for future platforms. Going from CPUs to GPUs has been an incredible challenge. I don't know what's going to come next, but I'm sure that it's going to be, again, very human intensive, and we won't have good ways of automating the portability of software to those next platforms. But overall, the one message I guess I want to leave you with is that if you can do just one thing, try to raise the awareness of software as a key element of research. When you talk to people, make sure they understand that research today can't happen without software. Okay, with that, I'll say thank you and end. Let me just point out that there's a lot of other people that I've been partially representing work of, co-leaders, collaborators, people that I've just been talking to, people that have had interesting ideas have influenced me. And if you're interested in more about kind of what I'm doing, I have a blog that I write occasionally. Hopefully there'll actually be a post coming out this week or next week. And then I tend to tweet a lot as well. And so I'll stop at this point and see what kinds of questions and discussions we can have. Thank you.
Thank you, Dan, for your inspiring talk. It's work that has been on his way for 10 or more years. And thank you for sharing it with us. with our community in this talk. So, questions, please. If you have any questions, you can put it on the chat, or you can just raise your hand and open your microphone and ask yourself, please. Any questions?
Can I ask a question, please, Christina?
Okay.
Oh, hi, Professor Katz. I'm sorry if I mispronounced, but anyway,
No, very good.
I think you gave a great talk for us today. Thank you very much. And I had lots of ideas, and my brain was like, but one thing that really caught my attention was the start of your talk, when you were talking about how we are how we are in the middle of an economic life, right? And you talked about nudging the authors of tools because, well, we can, for instance, reframe their contribution of a tool-only contribution. You can also publish a paper associated with it. But did you think of nudging the users of tools? Because you talked about giving credit as a really important way to help the authors of tools. And did you think of anything like that? For instance, maybe something related to incentivizing the behavior of giving this credit among people who are really known in our communities, because other people are likely to follow on them. Do you have any thoughts on this?
So I guess I feel like we're trying to do that to some extent in the software citation work by working with publishers to make sure that they call for software citation in papers. And I've also been involved with some communities. Like just as an example, there's a workshop we're going to have next month with the high energy physics community, working with some of the big projects to try to define what their collaboration practices are in terms of software citation. So I think I've been primarily trying to work with different aspects of the community, but I don't think I've really thought about what you're saying, which is an interesting question as well, of trying to think of exemplar people to demonstrate behavior. And I don't know of anybody that does, so I think that's a really interesting suggestion. That would be.
Yeah, I saw that you were already working with checklists, for instance, for authors on how to cite, and that's certainly a way of nudging too, because you're like reminding them of what they can do. But I think there are other paths when you look for behavioral economics and strategies of changing behavior. I don't know, maybe that's something that can be taught for the side of users as well, because we are users.
Yeah, no, I think that's a great idea. I'll say that I'm right. My background is in electromagnetics, right, and computational science. It's not in sociology, and so I'm
Mine too.
kind of learning a lot as I go, and there certainly are areas where I haven't necessarily thought about all the different options that somebody with better knowledge maybe already knows. So I think this is a great idea.
Oh, thank you, and great work.
And then I have a question. Just in the beginning, you talked, and it was for me a very important slide about engagement. And engagement for me is a keyword for everything we do in life and society, community. And for my experience, I just the path is joining, collaborating with open source software in terms of technical engagement, then to reach to be aware of open science, and everything seems to fit Do you have any comments about that in your experience this 10 years?
I'm
or
sorry,
more?
I'm not sure that I understood that. Can you say that again?
Engagement, the word engagement. For me, in terms of my own experience, joining on open source software communities and their practices and their relationships, collaboration against competition, it was more intriguing when I had the contact more deeply with open science practice and now software. So do you think, is there any relationship for us as a community to software engineering community to use open source or to contribute with open source software and be easy to embrace open science practice, best practice?
Yeah. Okay. So I think that there's I think there's kind of two different answers maybe to that. So one is I think is how software engineers actually work together themselves, right? How software is shared, how people work collaboratively within their own community, which I think again is I mean kind of gets tied to reproducibility as well, and evidence artifacts that go with papers, for example. And so I think that clearly is moving in the direction of open science. I think the other part is this question about kind of about studying research software and understanding what current practices are, why they work in some situations, why they work less well in other situations, trying to look at research software as a subject of software engineering research, which there are a subset of people that are doing, but I would say a relatively small subset at this point. But I mean, I think in all of these cases, this is all ideally based on the idea of open science, of sharing, of collaborating, of trying to work together to improve the state of where things are.
Okay, thank you. Let me see, Rafael. I think another question is about, please, if you have any questions, if you make yourself comfortable to ask them. I see this is so huge and complex ecosystems involved and the academic and the open source, the scientific, so many variables and communities. So we talk about starting a RSE in a country, for instance, in Brazil. I think there are two ways. We think about having a bottom-up strategy of having people interested that just join together and things, they have motivation and engagement and collaborate. But there's also the bottom-up way of our institutions, government, and so on, recognize the importance of the open science and its practices and so on. And for Brazil, nowadays it's difficult. We are trying to be very positive about doing research and have the resources. So I think, what do you think about these approaches for bottom-up that always for me is okay, but in a country like Brazil or similar countries, what can we do to have this bottom up, this top down as well, because people recognize and work together and have these guidelines or incentives and so on for researchers and community.
Yeah, so I think I guess I would say that at this point, the RSE associations that have formed have all really been bottom up, right? At some point, funding agencies have recognized this and have started to support it once they see this is what the community is doing. In the UK, one of the funding agencies started giving out some RSE fellowships. In the US, we've gotten to the point where the funding agency, when they talk about their vision, they start using the RSE term and they start including that. But I think that, at least to me, this really needs to start with people, with kind of with this bottom up sense, where there's been efforts to do this more in a top down way. I would say that to some extent that's what has been attempted in Canada, which has not been successful up to this point. I think Australia is kind of a mix a little bit, where there are people at the bottom as well as people at a higher level that were working together, and that seems like that has worked. I'm not completely sure which of those happened first, though. So I do think that this is something that's kind of in the very classical sense of community organization, like outside of science as well, just in a much more broad sense, that when people come together and they realize that they have something they want to work for it, and there's a way of changing it, and they start talking about it, other people start listening, and ideally some of those other people will join in. And if some of those other people are in a high level position and they see this is something that they can kind of support and get behind, and that this is going to help them with their goals as well, better software, better research, then there's no
yes.
for that.
Okay, thank you.
Right. I mean, of course, with governments, there's always a challenge of understanding what the government is, but a different issue.
Okay. Okay, community, any questions? Is there anyone interested, motivated to join informal group at first to talk about these issues? Is there anyone interested? Can you ask that if you have any doubts, you can ask Dan, please. I see that Sergio is here. Alfredo, Alessandro, do you have any? Elisa? Okay, so then let me put up a question and see if people just discuss about this. I'll tell you about some scenarios and to ask for your advice. First of all, let's start with this community here. In 2011, with Fabio Cohn and other colleagues, we just performed a study on the status of the research software developed and published in our tools track. What's the status of the software that has been developed and published as a paper? So we found some, I think it's common sense, but few projects had proper information about its, let's say, registry or access. Some were not findable, modern health, or accessible anymore. And we didn't check for interoperability, of course, not these aspects, and also reuse. We could not find and access most of them in a community that deals, I mean, the academic research software. This is one scenario. And the other scenario is we have that now this incentives also for open science and open, not incentives, but interest. And also we have another question in Brazil that we are going to discuss tonight that involves, for a country like our country, the open access, and to avoid paywalls for having access to our own research. But there is a concern about to be visible by the international community, besides being visible to the Brazilian community. And but also this difficult in having open or not having open access. And our society is starting with a movement of asking for all SBC, the Brazilian Computer Society, sponsored events to use only open lib, not, for instance, to publish our proceedings in ACM or IEEE. Well, so there are two scenarios. The first one and the second one. I please, could you comment or share your experience, your opinion?
I don't know. I'm not really sure that I have anything useful to say. Yeah, I'm sorry. I don't feel like I have a good contribution to this discussion.
Okay. Any comments, Elisa?
I mean, yeah, maybe other people that are there do.
Okay, Daniel, here, Melissa. Yeah, thank you very much for your talk. I'm from São Paulo State, University of São Paulo, and nice to meet you here. Thank you again for this talk. I'm not a specialist in research software, but I'm working in the funding agency here in the state of São Paulo. And this agency, I guess, is the first one concerned with this aspect of research software. Then for the next project that next call for proposal, the intention is to consider this kind of software and provide money for these projects to develop this kind of software. We know it's very, very hard and costly to develop software in general. Then it's necessary to put extra money for these projects. Then our intention is to work in this direction. I'm working with Fabio Con. I don't know if you know him.
Yeah,
he's a great guy. He's invited me to work together in this group, internal group, to organize the document about how to guide these research groups to provide and to develop and to disseminate the software constructed in this project. The idea is to use open source licenses like GPL. Then it's important for us. We are funding agents. Then it's important to incentivize the research group to provide in this way, or like open source. Then for me, I'm not a specialist in this area. I just started to read something about FAIR, about this research software. Then for me, was very, very interesting to your talk, the perspective and the scope and the dimension about this research software is very, very large, more than I know. Then it's very interesting for me to see your talk today. Then thank you very much. I think this talk will be very important to the Brazilian community and to incentivize other funding agents to put money in this kind of software. Then congratulations for this talk and thank you very much.
Okay, yeah, thank you. I guess maybe just as two comments on that. One I think is that I think it's important for funding agencies to realize that they are already paying for research software. They're just not paying for it to be necessarily used more widely. And so I think the question isn't how much does research software cost? How much extra would it cost to take the software that's being developed and make it more fair, more shareable, more reusable? And I think if from that point of view, hopefully it's an incremental small cost compared to what's going on initially, and it should be seen as well worthwhile, at least in most cases, maybe not in all cases. The other thing I was going to mention is that so I mentioned the Research Software Alliance in my talk, and I'm the steering committee chair for that. We have in that group something that we call the Funders Forum, where different organizations that are funding research software come together and talk about what they're doing. And so Fabio has been an active participant in that from ProPESPI. And he has been, I think when he's talked about what the funding agency in Sao Paulo is doing, it's been quite exciting to others as well. Because I think they see it as, I don't want to say as a model to follow, but having aspects that really maybe become best practices for other funding agencies. So it's, I mean, so I don't know. So just kind of from the point of view of looking at this outside Brazil, there's a lot of funders across the world that are looking at Sao Paulo as developing a key part of these best practices.
Yeah. Okay, thank you very much for your talk again.
Thank you.
Okay. Any questions? Okay. We have 4 minutes. So I'm using this for thank you. I think this is something that your final slides about guidelines are very inspiring. I think we are at the point that each one of us can perform tiny, embrace tiny tasks and actions. And then after we embrace and understand, we engage and we try to engage more people and build maybe a community emerges of this. So I'm very happy because this subject it has you and your talk are very important for this this special community, software engineering community in Brazil. And I hope that these guidelines inspire. Your talk is inspires our community, and also to embrace step by step some good practices. And I hope to have more interested people and questions about this, because I think even as young researchers or as senior researchers, this is a topic that is very important. I think the young researchers maybe embrace in a way, and senior researchers have another channels to work and to embrace in different levels. So I hope the collaboration with Brazil and Fabio, Alfredo, and that I hope that a group emerges from to have this important topic embraced by people, by agencies, by government in Brazil. So this is, I think it's very important. I'd like to thank you a lot. thank you very much, Daniel.
Okay, well, yeah, thank you as well. Again, thanks for the opportunity to do this. And if there is anybody in Brazil interested in the RSE idea locally, please do get in touch with me, and I'll try to put you in touch with other people. Again, I feel like if there's enough people in Brazil that want to do this, it would be great. And maybe my job is just to help them talk to each other, and then to get out of the way and let things move forward.
Okay, so people, let's thank Daniel. Okay, if you can open up your cameras and